Alright, Algebra 1, this is Mr. Geisway, and today we're going to be looking at your 1-3A notes, and what we're going to be doing is greatest common factor of monomials. So you have done greatest common factor before, so things like 14 and 42, and what we're going to do is just look at basically a list of the factors and find the biggest number that they both have in common. So, for example, 14 has factors 1 times 14 is 14 and 2 times 7, and for 42 we have this list here. I'm not going to read them all off. You can see them there. So basically what we do is we just look through our list and we say, all right, what is the biggest number they both have in common? One of the common mistakes that I get a lot here is people will say, well, 7 is the biggest number, but actually 14 is the biggest number that they both have in their list. Okay, so just keep that in mind because a lot of times that is a common mistake there. All right, next bell ringer. Least common multiple of 8 and 12. I got the lists written right here. So let me get rid of this screen. Here we go. So the biggest number that these both have in common would be 4. Okay, so hopefully you remember doing this. This is something that you have covered before in a previous math class. I don't know when, but it's something that you've seen before. So what we're adding in algebra is we're adding the variables to this. So first up, monomial is an expression of one term, blah, blah, blah. You can read the rest of that. But basically a monomial is something that has a single term. There are no plus or minus signs. Okay, so if you see a plus sign or a minus sign, that's indicating that there are multiple terms, and then it becomes a binomial, trinomial, whatever. So something like this. Okay, now don't mistake in a negative, like I have a negative 1/2 there, for a minus sign. Those are different. So moving along here, the greatest common factor is used when we're factoring, like I did in those bell ringers. We're basically just making our sets of numbers, and then we look at the variables. All right, so GCF is the greatest, or just the biggest factor that will divide evenly into a set of numbers. So, you know, a number will divide into another number. It could be a fraction or a decimal, but that's not what we're looking for. We want something that divides evenly. Okay, so that's why we have that. You know, that's a key word there. It will divide evenly. It has to go in a whole number, no decimals, no fractions, anything like that. Okay, so let's look at some examples here. So what is the greatest common factor of these two? So if we start with 6 and 12, just like we did in that in the bell ringer, so we start with 6. We say, well, the numbers that multiply to give you 6 would be 1 times 6, and the only other ones we would have are 2 times 3, right? And for 12, we would have 1 times 12. Try to space these out. 2 times 6, and 3 times 4. Okay, so I have a little bit of a gap there, but that's okay. 1 times 12, 2 times 6, 3 times 4. So the biggest number that they both have in common is the 6. All right, so we know the GCF of the number is 6. So here maybe the new part, I don't know if this is something you guys have seen before or not, but the new part for algebra is the variables. So we have an x to the third and an x squared. So when you're doing GCFs, you look for the biggest number that goes into your numbers evenly, and then it's the smallest exponent. So my smallest exponent here is 2, so x squared would be the GCF for the variable. Okay, so make a note there, biggest number. So the biggest number, that's a number sign, and the smallest exponent. Okay, that's what we're looking for. All right, so let's keep going here. Some of the problems on your homework will be a multiple choice problems or whatever. We still need to make sure that we're showing the work for those. So what is the GCF of all of this here? Let's start with our numbers, 9, 6, and 15. So we want to know what is the biggest number that will divide into 9, 6, and 15 evenly. So for some of you, you can probably just look at that right away and know what the answer is. But some of you may still need to make your list, and that's fine. Like I said, everybody's on a different ability level, so we can write our lists, all right? So 9 is 1 times 9, and 3 times 3. We don't need 2 copies of 3. We can just put 1. 6, we made that in our last example. So 1, 2, 3, and 6. And 15, we have 1 times 15, and then 3 times 5. Okay, so if we look over these and we say, all right, what's the biggest number they all have in common? Well, they all have a 3. Now remember, it has to go into all 3 of these terms. It can't just be 2 of them. It has to go into all 3 of them. Once you can tell me that, you can look at your multiple choice answers and know the correct answer is A, right? So we know the answer is 3. And if we look at our variables up here, the smallest variable that we have for P, well, we have a 5, a 4, and a 2. So we know that's P to the second. And then we want to look at our Q exponents. Keep in mind, if there is no exponent written here, that exponent is a 1. Okay, it's not a 0, it's a 1. So the smallest exponent for Q would be 1, or we could just write the Q. All right, so we know that's our answer, which again, that lines up with what I picked. Next example, same thing here. We want to find out what is the GCF. So look at your numbers, 6 and 22. So 6, again, we've seen this one twice already. So 1, 2, 3, and 6. Another thing you can do is just take these numbers and see, well, which of these numbers will go into 22. Since we're looking for the greatest common factor, let's start at the right-hand side. Does 6 go into 22 evenly? Well, no. 6 goes into 24 evenly, but not 22. So 6 is out. How about 3? Does 3 go into 22 evenly? Well, no. 3 goes into 21, not 22, so 3 is out. So how about 2? Does 2 go into 22 evenly? Yes. 2 goes into 22 11 times, so we know that 2 would be the GCF. Okay, so this is another method, another way of finding a GCF, all right? So after that, we know that B is out, and we know that D is out, okay? So now we need to look at our variables and see, well, what variables, what exponents for these variables will give us the correct answer. So remember, we're looking for the smallest exponent. So U, well, both of those U's have a 3, so U to the third. And then for V, we have a 2. And then remember, this V right here has a 1. So it's going to be V. And then W, again, this W right here has a 1. So it's W to the first. So this is our correct answer, which is C. Okay? You can ignore these little dots over here. These were pulled from a multiple choice thing that you would select those, but you can just circle your answer. That's good. All right, for example D, what I want you to do, pause the video. I want you to try this one. So pause it, see what you get for your answer, and then check back and see if you have it correct. All right, so for the GCF, again, I'm starting with 21. So my factors for 21 are 1 times 21. And then also, so 2 doesn't go in, 3 does, 3 and 7. And then if we look for other factors, 4 doesn't, 5 doesn't, 6 doesn't go in, and then we get back to 7. So this is it. This is our only set of factors. All right, so let's do what we did in that last problem. We say, does 21 go into 77 evenly? So you can use your calculator, do 77 divided by 21. You will get a decimal, so 21 is out. How about 7? Well, 77 divided by 7, that will give you a whole number. That gives you 11. So we know 7 is our GCF for the numbers. Look at your exponents. We want the smallest exponent. So if you look at your x's, smallest exponent for x is 3. And your smallest exponent for y is also a 3. So correct answer again, we end up with C. E, again, same thing. Pause the video, see if you get the correct answer, see what you get, check back, make sure you fix it if you don't get it correct. But again, I just want to encourage you to try these on your own and then see how you do with them. So for 6, again, we've seen this a couple of times in these notes, so I'm just going to list them out. So for 6, if I start at 6, if I do 66 divided by 6, that works. So I know 6 is my greatest common factor. Okay, so 66 and 66, those are both out. So 6 is my biggest number that will go into both evenly. And then smallest exponents, well, x to the third is in both of them. And then if we go on to our y's, we have y to the third and z to the fourth, so that's going to be y to the third. And then here's a thing that kind of gets a little tricky, and you can look at your answers and already know the correct answer is C, because this one has y to the fourth, so we know the correct answer here is C. But z to the second is in this term, But over here we don't have a z. So that basically, if there is no z, that means we have z to the 0. And z to the 0 is, the smallest exponent then would be 0. So that would be included. So there is a z to the 0 here, but we just don't write it. All right, so that's just something I just wanted to explain. It's not really that important for your answer because you do have the correct answer here, but it's just something I wanted to point out. All right, F. So remember, we need all three of these numbers, okay? So I'm going to look at all three of them. So 42, we had this one on the bell ringer. So 1, 2, 3, 4 doesn't go in evenly, 5 doesn't go in evenly, 6 does, and 7, and then 3 and, I forget what it was, 14, 3 and 14, and then 2 and 21. There we go. And then 42. Okay, let's look at our list for 30. This will be a smaller list. 30, well, maybe not. 1, 2 goes in evenly, 3 goes in evenly, 4 does not, 5 does, 5 and 6. And then 3 and 10, 2 and 15, and 1 and 30. So that's our list there. So not much smaller. It's actually the same. So number 6, or not number 6, but the number 6. Again, 1, 2, 3, and 6. So if we check out our lists here, if we start on the right hand side and we want to see, all right, well, which of these numbers is in every list? The biggest number that's in every single list here is 6. Okay, so we're doing the same process that we did in those last, 4 problems or whatever. We just have 3 numbers instead of 2. All right, so we know it's 6, and then again we're going to look at our biggest exponents. So smallest exponent. Smallest exponent is x to the 3rd, and then smallest exponent for y is just y, because this is y to the 1st, so that's the smallest exponent for y, and that is our final answer there. We ended up getting B. So 6 x to the 3rd y, final answer. All right, so again, if you have any questions on those type of problems, please let me know. G is a kind of a different problem where you're basically given one of the monomials is 6xy squared, and then it says one of the two, and then your 6xy squared is the GCF. One of your monomials is 12, so you're asked for the other monomial. Okay, so we're going backwards here. So if you look at F, in F we were given 3 monomials and we were asked for the answer. In this one, we're given the answer is 6xy squared, and we're asked to find out what the other monomial is. Okay, and these are the type of questions that you're asked on Keystone tests and all those standardized tests. So we want to make sure that we can understand what's going on here. So if we look at our answer, okay, x is the smallest power of 1 is the answer. Since this one has a power of 2, one of these that has an x to the 1st power has to be our answer. So C is out because that doesn't have an x, and then D has an x squared, so that one's out. All right, so now we've narrowed it down to these two. Our answer is y squared, which would have come from this y squared right here, and you can see that these two both have a y exponent higher than 2. Okay, so the y variable doesn't help us, but what we're going to have to do is we're going to have to take our numbers. So if I have 12, which of these two numbers will give me a GCF of 6? So if I look at 12 would be 1, 2, 3, that's supposed to be a 3 and a comma, kind of scribbled together there. Let me fix that real quick. 3, 4, 6, and 12. Now the problem with 24 is going to be in my list. I did it again. Sorry. When I make my list for 24, so 4, 1, 2, 3, 4, 6, 8, 12, and 24. So when I make my list for 24, you can see that 12 would be our GCF here because that would be the smallest number. So that's a problem because our number should be 6. Okay, so that means that 24 would be out, which means that A is not correct, and our correct answer has to be B. Okay, so again, this one is kind of a confusing one, and some of you may have questions on this, and if you do, send me an email, send me a private comment, and we can talk about this a little bit more in class, but I just wanted to point that one out to you because that is a common one that you can expect to see on your Keystone exams, so just keep that in mind. But if you have any questions, just let me know.